Welcome to the System Design series. In this video, we'll explore Scalability Fundamentals. We will learn to understand the requirements and challenges involved in designing scalable systems. Scalability is the ability of a system to handle an increased load by adding resources while maintaining performance and reliability. It's about ensuring your system can grow to meet demand without sacrificing speed or stability. There are mainly two types of scaling. First, vertical scaling, which means adding more power to an existing machine. This is often called scaling up. Second is horizontal scaling, which involves adding more machines to the pool. This is referred to as scaling out. Let's compare vertical and horizontal scaling. Vertical scaling is simple to implement, requires no code changes, and offers consistent performance. However, it has hardware limits, presents a single point of failure, and can be expensive at scale. On the other hand, horizontal scaling has no theoretical limits, offers fault tolerance, and is cost-effective. But it involves complex architecture, potential data consistency issues, and network overhead. When designing for scalability, it's important to consider several key requirements. These include performance, which is about maintaining response times under increased load, availability, ensuring the system remains operational during failures, consistency, guaranteeing data remains accurate across all nodes, and cost efficiency, balancing performance with operational costs. There are two key scalability challenges. First is bottlenecks, which is caused by database limitations, network bandwidth, memory constraints, and central processing unit processing power. Second is complexity, which is caused by the use of distributed systems, data synchronization issues, load balancing, and difficulty in monitoring and debugging. Here's a simple example of a round-robin load balancer implemented in Python. The class load balancer distributes incoming requests evenly across multiple servers in a circular fashion. The constructor takes servers as the input. The getServer method returns the next server in the list. Here are the key takeaways from this video. First, choose vertical or horizontal scaling based on your specific requirements. Second, identify and address bottlenecks early in the design process. Remember, scalability is about planning ahead and making informed architectural decisions. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.